All right, so in this lesson, we are going to solve word problems. Solve word problems by graphing a system of equations. By graphing a system of equations. Graphing a system. All right, so example number 1 reads, Abrazel and Andrea are collecting pictures of Mr. Lopez. Oh, this is Des. This should say Aubrey. So Aubrey already has 10 pictures and collects one more every 3 days. Andrea only has one but collects 5 pictures every 6 days. When will they have the same amount of pictures? How many will they both have? So here's our question. When will they both have the same amount of pictures? And then how many will they have? So let's express this using an equation for each of these. So Andrea and Abrazel are collecting pictures. So we're ultimately talking about the number of pictures. So we have the number of pictures for Aubrey and the number of pictures for Andrea. And so Aubrey already has 10. And she collects, so she adds an additional 1 picture every 3 days to her collection. So she starts out with 10, and she gets 1/3 of a picture on average per day. Andrea, on the other hand, has 1 picture, so she starts with 1 picture, and her collection increases by 5 pictures every 6 days, or 5/6 of a picture on average per day. And so all I have to do is graph these, like right here. You know what I'm going to do? I'm actually going to write, well, I'll do it like this. I'll make this one pink, and I'll make this one, I'll just leave that one blue. So here are the pictures, or the y-axis will be the number of pictures, and the x-axis will be the number of days. So let's make sure we label like how we're counting. So 1, 2, this goes 5, this is 10. And then 1, 2, that's 5, and that's 10. Okay, so Aubrey. I need to put a B here because that looks too similar. Okay, Aubrey starts with 10. You know what, I'm not going to make that color. Okay, we'll start Aubrey with 10. And her pictures will increase 1 by 1 every 3 days. 1 picture every 3 days. 1 every 3 days. 1 every 3 days, and so on and so forth. All right, so I can do, I think, better than that. Maybe not. These lines always trip me out. Okay, and this will be Aubrey. Aubrey's pictures, right? Let's graph Andrea's pictures. So Andrea starts off with 1 picture, but her collection increases by 5. 1, 2, 3, 4, 5 every 6 days. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Oh, it looks like it's going to intersect there. Well, it will intersect there. And this is Andrea. All right. So we can tell that right here, what should I make it? I have to go back to blue. Right here. That blends in too much. Let's make it purple. Okay, so this is our solution. So this is 10, 15, 16, 17, 18. And this is 5, 10, 15, 16. So our shared solution is 18, 16. Remember that 18 is the number of days, and the 16 is the number of pictures. So 18, 16. And in terms of the word problem, let's describe this, or let's describe 18, 16 in terms of the word problems. So right at 18 days, Aubrey and Andrea both have 16 pictures. 16 pics of Mr. Lopez. Cool. Let's do it again. Example number 2. Jack has a bag of 16 candies. There's a hole in it, and he loses about 1 candy every 2 hours. His brother only has 7 candies, but he gains about 2 every 5 hours. After how much time will they both have the same amount of candy? How much candy will they each have? So what I'm going to do is slightly different. So Jack has a bag of 16 candies, so underline Jack. And he loses 1 every 2 hours. Ooh, it's a little low. Now his brother, brother has 7, but he gains 2 every 5 hours. Okay, and the question is, well, let's put that in purple. So after how much time will they both have the same amount of candy, and how much candy will each person have? Cool. So let's talk about the number of candies. Let's talk about the number of candies. Number of candies for Jack. And the number of candies for his brother. So we will, number of candies for the brother. Okay. So Jack, the number of candies Jack has, starts off with 16. But there's a hole, so he loses. So the 16 decreases. The amount of candy he has decreases by about 1 every 2 hours. So about a rate of about half a candy every hour. And his brother, on the other hand, only starts off with 7 candies. But the number of candies increases. It gains. He gains about 2 candies every 5 hours. Or about 2/5 of a candy on average per hour. So let's go ahead and mark this. So this will be the number of candies, number of hours. You can also put time and then hours, but you're fine. So 0, and then here's 5, here's 10, because we're counting by ones. 5, 10. All right, so Jack starts off with 16, so 15, 16. And he decreases about 1 every 2 hours, 1 every 2 hours, 1 every 2. The more dots I have, the better I think sometimes I make the line. So, okay, that's okay, I guess. I hope it's not over here. And then the candy for his brother Jake actually starts off at 7. The number of candies he has starts off at 7, and it increases about 2 candies every 5. 2 every 5. Oh, there it is. And then 2 every 5. So this is the brother. And I forgot to label, this is Jack's candy. The amount of candy that Jack has, the amount of candy that his brother has. And then here is the common. So I should do that probably right here too. Okay. And this is 10, comma, 10, 5, 10, 11, 10, 11. Don't forget that this is the hours and this is the candy. I think I should probably, that's a little better, I guess. It's kind of hard to read, so I'll put hours. Okay. And so this means that after 10 hours, they will both have 11 pieces of candy, or at 10 hours, right? Because after that, after 10 hours, they both have different amounts again. So at 10 hours, that doesn't even look like hours. I think it's just that word. Maybe I need to. Okay. At 10 hours, Jack and his brother I can write this a little better. Brother both have. So after 10 hours, Jack and his brother both have 11 candies. Oh, almost forgot to write my solution here. 10, comma, 11. And that is it. Thank you.